Okay, here we are, ITS148. It's February 21st, and we are in starting chapter 9, which is a short chapter on strings or date, time, strings. And so I think I should be able to finish this up today. And so Tuesday, I can go over some previous assignments, or I'll probably have maybe I might have a new assignment for you, or maybe not. But anyway, so we can sort of get caught up on that. I haven't helped you with assignments much lately, so that'll be nice. All right, so let me share my screen here. And I'll put this down there and put this down here. All right, so we are February 21st, class number 14. And if we I could use the slides, but I think I'll use the textbook today because I think the textbook's better. And so if we open up this textbook and we view it, two-page scrolling, which I like. Let's go to chapter 9. All right, chapter 9. So in this chapter, we're going to learn about date, time. See, let me see what happens if I go to chapter this thing here, chapter 9. Yeah, okay. So can I do this? Can I still scroll? Yes, I can. Okay. Can I? Okay, good. So, so in this chapter, we're going to learn how to deal with date time strings, which is always kind of tricky in languages. We have to learn what the time increment is that C# chooses to use, and that's how we determine how we add and subtract time values. In old-time Unix, Linux, it was the number of seconds. Time zero was January 1st, 1970, and after that, each second, time 1 was 1 second, time 2 was 2 seconds, and so on. So each increment was a second, and so here, that was Greenwich Mean Time. So in Hawaii, actually, our time 0 would be 2 p.m. December 31st, 1969. Anyway, in Excel, it's a day. Each unit is a day, so there's fractions of days, of course. In JavaScript, it's a millisecond, I believe. In C#, it's 100 nanoseconds, and as you know, a nanosecond is 2 to the minus 9th. So 100 nanoseconds, there are 10. So and it's called a tick. So there are 10 ticks to a millisecond. So anyway, so we're gonna learn how to create date time values and how to go back and forth between them, and then we're gonna learn about strings. And there's a string class and there's a string builder class, and the differences have to do with how they're stored and how efficient it is to manipulate them. And then we learn about formatting numbers, dates, and times, and we've done a lot of that already in 128. You know, toString, using toString. So as with this textbook, if you have the textbook, you know that on the left side of the page, at the left, you open up the textbook. On the left side is the content of the left side is the same as the content of the right side. The left side is text, descriptive stuff, and the right side is sort of a summary and examples. And so if we go through the right side here, I kind of like that until we need to look more at the left side. We have here, let's see, how do I make this well? So the syntax for creating a date time value. So the type, let me fiddle with this a little bit. I want to make the size a little bit skinnier. Okay, so the class, the name, the type, like int or string or decimal or whatever, it's called date time, and then this would be the variable name, and we say it's a new, we're declaring a date time variable, which is a new date time variable, and then this then we can define an initial value, you see. So here's an example where we include as arguments to this date time constructor here the year, the month, the day, and we can optionally include hours, minutes, seconds, and milliseconds actually. And so we can also create a date time value using .parse, datetime.parse, just like we can create and having a string in there. Just like we can create like an integer value, an integer variable or a decimal variable, like for example, reading from a text box, string value from a text box, it's the same idea. We can create a date time variable like parsing a string, and the string of course can be the text property of a text box. There's also try parse, just like with numbers, and it's a string and then an in-out or an out variable, and if it's successful, this whole thing returns true. If it's successful, this is true. If it's successful. And so this can be the if clause, the Boolean expression part of an if statement. If it's true, we do something. If not, we output an error. So here's some examples of creating datetime values. This one is going to create a new variable, a new datetime variable containing January 30th, 2016. And the default time is the very beginning of the day, which is 12 a.m. And here's an example where it's January 30th, but we're saying that it's going to be 2:15 in the afternoon. See, 14 hours, 15 minutes. It's this. Here we're using the parse, and same day, January 30th, 2016, 12 a.m. And we can also do this. The parse is pretty smart. And these are the different these are the different kinds of date formats that can be successfully parsed. Other languages have more elaborate parsable datetime formats. I've never tried them in C#, but for example, in PHP, there's a string to time method which you can put, yesterday, and it'll figure out what yesterday is and convert that to a time. But for C#, let's just stick with these. And then, so here's an example of we're reading a date from a text box. Presumably, a TXT would be a text box, and parsing it. And here's the same kind of thing where we're declaring a datetime variable without initializing it to anything. then using try parse to initialize this invoice date variable. These are valid time formats. So you can use the date time structure in .NET to create and work with dates and times. There's summaries here. Create a date time value and then use the new keyword. This is all describing what we see up here. Parse and try parse. If you omit the time value, it's set to 12 a.m., first beginning of the day. And date is stored in a 64-bit signed integer that represents the number of ticks that have elapsed from the beginning of AD, I guess, January 1st, 0001. Does anybody know, I'm not really up on the Bible or anything. Does anybody know when Jesus was supposed to be born? Was this when Jesus was supposed to be born? Or is Jesus really supposed to be born December 25th?
Well, it wasn't really supposed to be December 25th.
Oh.
They say that wasn't true. I don't know when it really was
Oh.
supposed to be.
Well, anyway, so.
But it was a pagan holiday.
About?
I know more about the pagan holiday.
Oh.
Like the winter solstice and things like that.
Oh. Okay. All right. Well, I had lazy parents. I never went to church, so I don't know. I guess I'm a heathen. So anyway, that's great. That makes things a lot easier. When we're with Unix date time, it's like I was born in negative time because I was born before January 1st, 1970. I like this a lot better. Anyway, so from this you can actually figure out how today's date and time is represented in a 64-bit signed integer. It's signed. That's great that it's signed because then we can actually store dates that happened before. We can store BC dates. But anyway, ticks is 100 nanoseconds. So remember that when I was reviewing the quiz questions, I had to look up what a tick was. I thought it was I was going to replace it with 100 nanoseconds, but I guess we'll just stick with ticks here. These are some date time properties that once you've declared this date time variable, there's some date time properties that we can use and some methods. So here, let's say we have this is a date. So here's how we would set a variable, a date time variable called current date time. This is how we would set it to right now. So you would use this .now property. I guess it's a property. So I guess if well, it's pretty early in the morning. And today there's .today. You may recognize these from Excel. The now function and the today function are the same, are similar in Excel. And then these are date time methods used for formatting the date and time. To long date string. It's a method that you would hook onto current date time like this. And so the to long date string would be this long way of describing the date. Short date would be this shorter notation here. Time, long time would be looks like this. It's got the seconds in there. And short time would just look like this. The now and today properties are static properties of the date time structure. That means you don't need to actually declare anything yet, or you don't need to declare. You can just use it. And so once you've defined a date time variable, you can, sort of extract out portions of it, properties. So, once you've defined it, you can say the date returns the date time value with the time portion set to 1. The returns the date time value with the time portion set to 12 a.m. So it's just the date portion of it. So is there an example down here? So that would be, well, I guess it would be this, either this or this. So you define a variable, you've assigned it a value, you've assigned it a date time like this. And then there's a date property, there's a month property, which just returns an integer with the month portion. There's a day property, which returns an integer with the day portion. There's the year property, which returns the year portion, hour, minute, second. Time of day returns the time span value that represents the amount of time that has elapsed since 12 a.m. So it's basically just the time of the day, obviously. And day of week would be the member of the day of week enumeration that represents the day of the week. And a day of year would return an integer for the numeric day of the year. And then these are methods, which this returns a number of days in a specified month or year. And this returns a Boolean value which tells you if it's leap year or not. So you put the year in there and it'll tell you if it's leap year or not. So here, days in the month. Returns the number of days in the month. You have to have the year in there because, February can change. So here's examples. You've defined a variable called current date time, which is this, when this was assigned. And then you can get the month out, get the hour, get the day of the year, which is number 30th day of the year. And you can also, as an example, these are examples, here we're just using the structure, the number of days in February of 2016, it's 29 because it's a leap year. And whether or not 2016 is a leap year, yes, it's true. And so here we've a code that uses the day of week property and enumeration. So this is, enumeration was talked about in the last chapter. Basically, you define all the values, and you can refer to them like this. So there's a day of week. So it's, let's say you can test it. So you say the day of the week that we're talking about, this thing here. It's enumeration. It's going to be, dot Saturday, dot Sunday, dot Monday, dot Tuesday, and so on. So here we can say, like for example, if we grab out day of the week and it's going to be a value that's the enumerated value, day of week, and it's going to be equal, internally it's actually like an integer. It's indexed and everything, but you're able to refer to it using this dot notation. So here we're grabbing out the current day of the week, or the day of the week of the current of this date time variable. Presume if it's this January 30th, 2016. I'm not sure what that is. January 30th, 2016. Let's see. I'm being stupid here. January 30th, 2016 is a Saturday. January 30th, 2016 is a Saturday. Okay, so let's say it's this, and so the day of week would be Saturday, and so this would be true. If day of week is equal to Saturday, it's true, or Saturday or Sunday, then it's a weekend. And so that's what this would evaluate to. And we can perform operations on days and times, dates and times, and there are these methods here that help us. So we can add some number of days. You know, you recall we're dealing with ticks here, okay? So we're dealing in 100 nanosecond increments. So we have a day. We've declared a variable called date time, and we've defined it. We've initialized it as March 1st, 2016 at 1:28 p.m. And we decide to add 2 months to it. So this is how we do it. We just take this date time variable, and this is an expression. Okay, this doesn't actually change the date time variable, I don't think. Yeah, it doesn't. This takes the date time value. Of course it doesn't. This takes the date time, whatever the date time is, adds 2 months to it, and this is a new expression, and this assigns that new date time to this new date time variable, which we've declared this variable called due date, and it's a date time variable, and we've assigned the value 2 months from whatever this is. And then we can, and here, this is what it looks like if we add 60 days to it. So 60 days added on to March 1st, 2016 is going to be, I guess it's going to be 31. I guess it's April 30th. Sounds close. So now due date is April 30th. Here we're going to date time. We're declaring a date time variable called runtime, and we are setting the value to whatever date time is plus 30 minutes. So this is what date time is right now, and we're adding 30 minutes onto it, so it becomes 1:58 p.m. as opposed to 1:28 p.m., and that's what this runtime value is going to be. And here we're actually adding 12 hours to it. So 12 hours, yeah, so 12 hours added on to 1:28 p.m. is going to be the next day at 1:28 a.m. So here, this is how we add a time span. Add a time span, okay. So we define a new date time variable called current date, and we set it equal to today, and this is apparently today when this was written. And then we here we have a parse. Then we have another date time variable called due date, which I guess was defined up here, and we set that equal to we set that equal to February 15th, 2016. Okay, so the time span where we take here we take the due date, which is February 15th, 2016, and we subtract the current date, which would be January 30th, 2016, and that's going to be, you know, 16 days. There's 31 days in January. So be 16 days. So this is 16 days. Days, hours, minutes, seconds. 16 days. So now it's a time span variable. All right. And here we're converted to an integer. Statement that uses the minus operator to subtract two dates. So it's a time span variable. So a time span variable is keeping track of a time span, which is going to be days, presumably days, hours, minutes, seconds, and so we can do operation. We can do this subtraction operation where we take the due date, which is currently February 15th, 2016, and we subtract the current date, and it's the same. This is the same thing. Uses the minus operator instead of the subtract method. Here's an if statement that uses the greater than operator. So if the current date is greater than the due date, then we set this past due variable, Boolean variable, equal true. We can also do, I assume we could do past due equals current day, current date, greater than due date. Because this is going to evaluate to true or false, and we're setting, and this is a Boolean variable, so presumably this should work also. Period of time stored in ticks. Okay, strings. There's strings and there's a string builder class. So let's start with the string class. This is what we're familiar with. We learned about this in 128. Common properties with strings. A string is just kind of like an array of characters. And so when we talk about, so we have a string, and then we talk about this indexer. It's got the string variable followed by a square bracket, some integer, and square bracket. That's simply the character at that position. So this index returns the character at that specified position. It's an example here. We've got the character of string characters, A, B, C, D, F, G, and so this character, it's a variable B. It's called B. It's equal to B. But this is the index, and it's going to return a character. It's not a string. A character is different than a string. A string is like an array of characters, so it's like an array. So with strings, there's a length property which returns the number of characters, just like an array. And these are some methods. So this is a method. We have the string. Some examples here, maybe. Substring, remove, insert, index of. So anyway, so this one will return true or false if the string actually starts with this substring. Returns a Boolean value that indicates whether or not the string starts with the specified substring. this substring. And this one's for ends with it. It ends with it. Returns a Boolean value if that's what it ends with. This will return an integer that represents the position of the first occurrence of the specified string. So, so let's say you have, you know, say you have my name, Rich, and you want to know the index of, you know, index of IC, you know, something. Let's say you have a variable S equals, say, string, and G string S equals this, quotes, double quotes here. And you want to say S dot index of IC, like that, just like that, is going to return 0, 1. It's going to return value 1 because that's where the starting position of IC is. It's at 1. That's IC. Now, if you were to add on here, put a if we were to put something like let's see, let me do something better. Let's do I should have picked a different name. But if we do like 3 or 2, let's do 2. This says, this is going to be return the first index, the first occurrence of IC starting at position number 2. Well, position number 2 is right here. 0, 1, 2. And so it's going to return -1 because there is no IC after starting at position number 2. And this is last index. So so let's say you want to well, this is used to parse, as they say, parse a string into component parts. Like and we'll see an example later. In fact, we'll see an example of these in a moment. Okay, so let's say you have an address. You know, let's say you have an address. You know, 1180 space Mokuhano space street space. Yeah, let's say that's enough. So that's my street. And so if we're looking for spaces, let's say we want to parse this, and we want to parse off the house number, then we would be looking for the first occurrence of a space, and that would be the separating the house number and the street. And if we were looking for the last occurrence of a space, that would parse off the street from that would parse off the name of the street from the designator, or the, you know, street, avenue, boulevard, highway kind of thing. This is an insert, which will return a string with the specified string at the inserted at the beginning of the specified position. So so we have a string. Recall this is a method, and so we can actually insert another string within that string, and starting at the start index. And this is pad left, which returns a string that's right aligned with padded spaces on the left. And this is good if you want to, you know, let's say you have a bunch of street addresses. Let's say you have a street that's got a bunch of addresses on it. It's got a bunch of house numbers on it, okay? And you want to sort the, and let's say it's, you know, Kaneohe or someplace where there's hyphens in the street. I mean, it doesn't even have to be that. Sometimes you might want to right justify a bunch of strings because you want them to sort properly. If you have some streets that have like, it starts at like, you know, some like starts at like 900, you know, Baratania, and it goes up to 100 and goes up to 1100 Baratania, and you want to sort those streets. You want to sort the house numbers. It's all Baratania, so you aren't just going to sort the house numbers because 900, you know, the string 900 is going to come before, no, it's going to come after 1100 if it's left justified, if it's not padded. So to fix that, you want to pad it, and so you want you know, you don't want it to be 900 Baratania. You want it to be like space 900 Baratania, and that's so then when it goes up to 1100 Baratania, the 900s will come before the 1100s, basically. All right, remove is like insert, except for you can remove some number of characters from a string starting at a particular place. You can actually replace. Let's say you have a string, like let's say you've got S, and you want to say S dot replace you know, I don't know, H with KY or something. S meaning this S. So what would that make S? Can anybody tell me? Let's say we have S and it's defined as rich, and we want to, what would this return? Well, we're replacing the H with KY. What would it return? Yes. Very good. I know all the rest of you had that in your mind, but you were just too nervous to speak up. And this substring, this returns a string that starts at the specified position and has the length, the specified length. Okay, so and the length is optional. So if we have a substring and we're just starting at you know, some value, then we are just returning a string that starts at that value and all the rest of the string. If we have a length, then we may be returning a substring that's within that string. If the start index is 0, then we're returning a substring starting at the beginning, and length could be some substring which is only a particular length. These methods here, to lower and to upper, we know about these already. In fact, we should know about substring already, and we know about to lower, to upper. That just makes everything lowercase, makes everything uppercase. I remember last semester we had an exercise, or we did something where we would capitalize. We capitalized the first letter of every word, and to do that we use substring to grab off the first character, and we did to upper, and then we use substring to grab off the rest, excluding the first character, and then we did to lower, and that would create something that's got, you know, first letter capitalized and so on. Trim is very handy to get rid of trailing spaces and leading spaces, and also gets rid of like returns and tabs and so on. And then split is you can take a string and you can split it, and it is split on the split character or characters. And we'll see an example of that. This is basically a split would be how you would, let's say you have a tab delimited spreadsheet. It's a common, say you have a spreadsheet and it's a text file, but you want it to be like a spreadsheet that's got columns. And so the two most common ways of having a text file represent a spreadsheet with columns is to either use commas, and those are called .csv files, comma separated values, or tab characters, tab delimited spreadsheets. Tab delimited means tab separated values. You can say comma delimited. It's like comma separated values. The advantage of tabs, I like tabs better because you will rarely see tabs in the middle of a you have a column of a column of string values, and you aren't going to have tabs in there. You rarely have tabs in there, where you can often have commas in there. And there's other advantages, but there can be more than one character, you see. So you could have, you could put a bunch of characters in there, and it'll delimit on any of those characters, not just the set of characters. So here's some examples here. This is a character string. We've seen that. This is a loop accessing each character of a string, and so with this here we're just adding a space in between. So we have this. We have a string variable, and we're calling it chars, and chars is equal to A, B, C, D, E, F, G, and then we are we can have a loop here, which a chars dot length is going to be 1, 2, 3, 4, 5, 6, 7. Chars dot length is 7. So we're going to loop from 0 to 6, and this indexes each character of this string called chars. 0, 1, 2, 3, 4, 5, 6. And 0 is A, 1 is B. And so what we're doing is we're creating this new string variable that's made up of chars, this char string variables, but we're inserting a space in between each character. And so that's why it comes out looking like that, spaces. This one uses for each. You can use for each just as easily. You have to declare another variable which represents the character. And it's got to be declared as a character because it's a character. Characters are different than strings in C#. So here's something that uses the start with and the ends with. Referring back to this string called chars, which is this A, B, C, D, F, G, this is going to return a true because chars does start with A, B, C. This is going to return false because chars does not end with A, B, C. So this uses index. Zero, 1, 2, 3, 4. I guess we can do this because it's a character. And the last index of space is, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And there's no space after that, so the last one's 15. This returns -1, of course, because there is no ink in this at all. Index 1 here is 4. And this is going to remove characters from 0 to 5. And so, and then this is going to insert this is going to, so this is going to remove the first 5 characters, which is 1, 2, 3, 4, 5. So it's going to remove the word Mike. It's going to remove the guy's first name. So now company name just is going to be Murrock and Associates. And then this inserts at the end, it inserts comma Inc. And so, and then what this does here, it replaces lowercase a and d with uppercase A and then ND. So this is, so at the end it's going to look like this. And you notice this and is fixed, sort of. The word Mike is gone, and comma Inc, comma space Inc period is added. 45. And this uses the 2 upper. So here's an example of how we capitalize things. So we start out with the word and this is going to make the first letter, the first character of the first letter uppercase, and this is going to take the rest of the letters, which is going to take substring 1 is going to take starting at character index number 1, which is n, which is the first n. This is character index number 1 right here. It takes the rest of them because there's no second argument here. It takes from n, from the first n on, and it's going to make them lowercase. So this is going to be n, e, and they're already lowercase. And this is going to be a, capital A. And so then when we concatenate them together, we get this. All right. Copies one string to another, you can do that. So here's some other examples. Does anybody remember who Edward C. Coop was? He was a Surgeon General under somebody, Clinton or somebody. I think. Surgeon General. So here we've got some spaces around Edward C. Coop, and this trims them, so now there's no spaces. This looks for the first index of space, and it's going to be 0, 1, 2, 3, 4, 5, 6. And this is going to test to see if the first, so what this does is this, string first name is space, first space is equal to -1. Okay, so this is kind of an interesting thing. If there is no space in the name, we're talking about this name here. If the first space is equal to -1, in other words, if there is no space, then okay, so if there's no space in the name, we assume we're going to assume it's just the first name that we have. Okay, so we're not going to assume it's the last name. We're going to assume it's the first name. However, if there is a space in the name, then we're going to assume that it's a first name plus a last name, and then we want to just grab off all the characters leading up to the first space. And so this is going to grab off, in this case, it's going to grab off Edward. here's where we can use this. Okay, well, here's a way of parsing out. We aren't using split. We're using parse. Here we're parsing off this. Let's say the address looks like this, and there's other ways to delimit strings, and this uses vertical bars to delimit strings. You're probably not going to find vertical bars in a spreadsheet of string that's got strings, certainly not addresses. So vertical bars are safe, and this parses them out. And this is a big long bunch of code here to sort of parse out all of these street, city, state, zip. And I do a lot of that, dealing with addresses and seeing if two people live at the same address, but they write the addresses a little bit differently. Here we're using the split method. And so split just creates, here's an example of doing the same thing where we're splitting. Here, well, we're gonna take off the first vertical bar and the last vertical bar because we don't need those. So first we're gonna trim off. If it starts with a vertical bar, we're gonna take that off. And if it ends with a vertical bar, it doesn't matter because we're only gonna use the first. So this removes the first vertical bar. I guess we don't bother with this last vertical bar. But then we use the split. And so what it does is splits that string. It splits this string into an array of strings, whereas there's the array of the strings are separated by the vertical bar. So the name it's array of strings. The array is called columns. And so after we do the split, the zeroth columns, 0 is going to be the first part, which is the street address. The second one is going to be the Dallas city. It's going to be the state, and this is going to be the zip code. So this is the right way to do it. This is the difficult way to do it. This is how you do it before you've learned the language as a split method. And here's an example of inserting hyphens in a phone number that's written like this, just looking like this. And here's an example of we have a date that's where we're separating the month, day, year with hyphens, and we're going to replace them with slashes, and so it looks like that. All right, so that's and to parse and try-parse. We know about parse and try-parse, but we don't know about this style thing. We can put this style thing in the middle of try-parse, and we can do it with parse too. So if we add this style thing inside between it actually looks kind of funny because the end of the parentheses ends up being here. So it's kind of weird. But there's no end parentheses. I've never used this, but it allows you to have some additional things inside the number the string that you're trying to parse. So it allows some extra stuff. By default, commas, decimal point leading zeros are not. Wait a minute, I might have this wrong. Are allowed in a decimal value when you use parse or try-parse method. If you want to restrict characters that can be entered, or if you want to allow additional characters, you can use the second argument. Oh, okay, yeah, just these. But if you want to allow additional ones, like dollar signs and so on, currency symbols, then you can add these, you can use the second argument. If you want to allow additional characters, you can use the second argument. So it's not used very often. Okay, the difference between a string type and the string builder class is just the way it's kind of stored. A string builder class allows you a string creates a string that can be variable length, whereas and this is like an implementation thing inside C#, so it doesn't really affect you that much, because a lot of what you can do is you can just use a string, but you notice that when we do all these things, these methods don't really manipulate the string at all. The string is defined, and it's defined as a fixed length. And if we want to change anything, we have to have an expression, and then we have to have another assignment statement. So if we have a name and we want to add some stuff to a name, we take the name and we concatenate something, and that's an expression, and then we have to have an assignment statement that changes the value. Changes the value. Whereas with the string builder class, we can actually manipulate the string itself. And so there are these, so we still have index, length and so on, but we can append a string onto a string, and it actually affects the string itself. So here is an example. We have a thing called, we create an address1, and we can define a length. And here's we define a phone number, and then we can just do this. And this takes phone number, and it inserts this to the phone number. So here, say we have a phone number that's, here we define a phone number as nothing, but it's got a capacity of 10. And here we're going to append. We're going to append that onto the phone number. So now it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here we're going to insert a period after in the third position. So now, and in doing so, we've gone over 10. So then it doubles it. It doubles the capacity to make it 20. This happens underneath, so you don't really have to even know about it. And here this inserts but in doing so, this inserts a period after the third one. So this thing here puts this period here. This thing here puts this period here. This thing here will remove the first four characters. So it's going to remove the 977 period, and we just end up with this. This is going to replace a period with a hyphen, so that's why it looks like this. And then this is going to take the phone number and do a toString, and it's going to set it equal to some label. So unlike string objects, the string builder string objects are mutable. String objects are immutable. What does mutable mean? Changeable. So string objects are not changeable. So all these methods just create a new expression, and then if you want to actually change a string object, you have to have another assignment statement. Whereas the string builder objects are mutable, which means you can have these methods which just change the thing itself. So this is a method that operates right on phone number. Whereas if this was a string object, this would just return phone number with that replaced, and you'd have to have this have to be an assignment statement. So you have to say phone number equals phone number dot replace. I don't know, do you see that? That makes sense? Let me try it out a little bit. Formatting dates and times. So this is the format string. We know about these, but you want to, and I think we might have touched on string.format, but we're about out of time here. So read this section and practice it a little bit, and after you figure out, it's pretty straightforward. So here this defines the format, and this is a pretty fancy format. This looks like a counting format, where if the it's this thing, it's enclosed in the curlies, and if it's a positive number, it's going to be this format. It's negative, it's going to be this format kind of thing. So it's going to look like that. This is I think we did cover a little bit of this in 128. And of course, there can be more than one. This is 2 values, and this is going to be the format for the first value, and this is going to be the format for the second value. This is 0, 0, and 1 is that. 0 is for the first one, and 1 is for the second one. So it's going to display out like this. So they're both currency formats. And dates and times also, if you want to do, you know, short and long, DDD is month, is day, month, year, and so on. So if you look, this is going to do current date, lower. So this is to specify them specifically how you want them. Interpolated strings. Oh, this is something new in C#. In C# 2015, you can instead of going through this longhand format, you can use this $sign format. It's just a different way of doing the same thing. See, this is the same as this. This is the same as this. As opposed to using the word format. Let's use this $sign thing. So anyway, it's 3 o'clock. That's it. And so read the chapter. And on Tuesday, today's Thursday. On Tuesday, I'll go over some assignment questions, and I'll probably have a new. I may have a new assignment for you. All right. So, are there any questions? How do I unshare this? Oh, I hope I shared my screen. I hope I shared my screen. All right. Anyway, so thanks for watching.